Hello everybody, welcome to Carl & Cymru revision sessions. The session this evening will focus on Maths and Numeracy Intermediate GCSE, will be presented by Mrs Claire Dixon from Penrith Halbert School in Swansea. The session will last around 45 minutes, where Mrs Dixon will run through the relevant content. If you have any questions during the session, please use the question and answer section within this live event. We'll do our best to answer your questions. The session will be recorded, and recording and any relevant resources will be uploaded to the e-sgol website under the Carl & Cymru tab. Thank you, Mrs Dixon, and over to you.
Thank you, Mr Casey. Okay, so for today's session, we're obviously going to look at Pythagoras Theorem. And to begin with, these are the topics that we're going to run through. Okay, there are some things that you need to know before we get into Pythagoras Theorem itself. And one of those things is that right to the top of the list there, squares and square roots. Okay, so that's where we're starting today. So just a reminder to you, a square number is the result of a number being multiplied by itself, and we use the power of 2 to represent squared. Okay, so I'm going to show you what I mean now. So what you may see in a question, or what you will need to use in your answer, will be something like this. So 5 with the power 2, meaning 5 squared. If we actually write down what that means, using what we've got above, this is 5 multiplied by 5, and then we work that out to get 25. Okay. So the questions on the right hand side, just two quick questions. This is a non-calculator slide. Over on the right hand side, you will see that I'll use a symbol to say whether it's calculator or non-calculator. Okay, so just have a quick go at those, and then I'll go through them in a few seconds. Okay, all right, I'm going to start going through them. Okay, so 7 squared means 7 multiplied by 7, giving you an answer of 49. It's exactly the same idea then with the next one, 11 squared, 11 multiplied by 11, 121, and that's all you'll need to know. Okay, with the calculator Pythagoras theorem questions that we'll do, obviously I'll show you in a few minutes how to access that on the calculator and use your squared button there, but they will be non-calculator questions you'll have to be able to do this with. So next one, the square roots. So the square root of a number is the number that when multiplied by itself gives the original number. So we use this kind of tick symbol that you can see in this yellow box here to represent the square root. You need to make sure that the line going across the top does cover the full number though, okay? So the square root of 36. So you will need to be thinking about what number would multiply by itself to give you an answer of 36. So that answer is 6. Because 6 multiplied by 6 is 36. It can't be something, some people go wrong with this one where they'll say, what's half of 36? Or they might write down 6 times 6 here. It can't be that. It has to just be the value that you would use to times by itself to get the number under the root. So if you can pause the video now and have a go with these on the right hand side, please. And then I'll give you a few seconds and I'll start again. So square root of 16, you're thinking about a number that multiplies by itself to get 16. And the answer was 4 because 4 times 4 is 16. Same idea with the next one, square root of 81. That one is 9 because 9 multiplied by 9 is 81. Okay, so these are things that we're going to need now throughout this lesson. So if we come back to what I started with, we've already just looked at squares and square roots. And I'm going to show you some labelling now. Pythagoras theorem is to do with a right angle triangle. It can only find the length of a side. It's not going to be able to find an angle. You won't be able to use an angle in it. Okay, but we're looking at lengths of sides. And for being able to do that, we have to be able to label the sides of a triangle. So the hypotenuse is the longest side of a right angle triangle, and it is opposite the right angle. I'm going to show you now with 3 triangles I'm going to appear in a second how to find them. You have to be able to label these, otherwise it'll be difficult to do Pythagoras theorem. So this little box down in the bottom left hand corner of this triangle, it represents your 90-degree angle, which is your right angle, and directly opposite that is then your hypotenuse. Some people put a H on there, some people will write hype, some people even write the word hypotenuse, but you have to be able to label it. Okay, so the next one Right angle this time is up on the top left. Directly opposite it is your hypotenuse. So this side here is, and it's always going to be the longer side. And the last one, right angle is down on the bottom here. You can see directly opposite it is your hypotenuse, and that one is labelled. Okay, so you're going to have a go now. Again, pause the video, please, and have some time now to draw those out or sketch them out and then label the sides of those triangles. Okay, so you should have been able to do these now. Opposite this bottom right angle here, directly opposite it, hypotenuse on that diagonal there. Question 2, right angle up on the top right, hypotenuse there. And then the final one, hypotenuse is down here on the bottom because the right angle is at the top there. Okay. Right then, so we've already done the first 2. And the next thing now is where we start to link into Pythagoras Theorem. You will have to be able to use your calculator to do this. For some of the questions, it comes up in both paper 1 and paper 2. So you need to know both methods. Okay, so using your calculator, you should all have your scientific calculator. And this is the button now I'll show you. So towards the top, where you've got an X and a squared there, you can see it is circled in red. That is the button you would use to square your number. So if I give you a question of 3.9 squared, you would type in 3.9, press that X squared button, equals, and obviously you'll get your answer. So if you can try that now, please. And the answer you should have got was 15.21. Right, so that's what we'll be using throughout the lesson. And then the same idea with the square root. So with your calculator, just to the left of the button you've just pressed, you should see the square root symbol with a little square underneath it. Now this time you would press that first. So you press the square root button, and then you would type your number in, obviously press equals. Sometimes you also have to press the SD button then, which is just above the orange delete button, and that will convert it to a decimal, but we'll have a look at that now. So can you try square root of 12.25, please? Okay, so you should have had an answer of 3.5. It may have come up as 7/2. And if it did come up as 7/2, press this SD button now that I'm marking out with the cursor, and you should be able to convert that then to your decimal. Okay, right, so now we're going to look actually at the theorem and how we can use it. We've got our squares, we've got our square roots, we know how to use our calculator, and the next thing now is our Pythagoras Theorem. So it's the relationship between the 3 sides of a right angle triangle, okay? And I'll say it again, it's really important. This is only used with right angle triangles. And this is the theorem that we have, okay? So you can see your right angle triangle in this kind of center part of my diagram here. And then there are sides that are labeled. Now, it doesn't actually matter what these sides are called, ABC. You can reorder the ABCs, you can call them hypotenuse, you can call them any letter. But the idea behind the theorem is that if you square the 2 shorter sides and add them, you will equal the longer side, which is we now know is called the hypotenuse. Okay, so over on the right-hand side, I've written down a squared plus b squared equals c squared. But I've already said you might see this written in a different format. You could have a squared equals b squared plus c squared. You could have hypotenuse squared equals, you could use h. Okay, it's completely can be changed as long as it's the same idea that this hypotenuse squared is equal to the sum of the other 2 sides squared. Okay, so now we're going to practice using it. So we're going to start by finding the length of the hypotenuse. This is a non-calculator question, and I've given you a question over on the left-hand side here where we've got 3 centimeters, 4 centimeters, and then x. So before we begin, label your hypotenuse. Remember, you find your right angle and it's directly opposite it, and just put a H or something on there to label that you know that's the hypotenuse. So that is going to be the side that we would square, and then it's equal to the other 2 sides. So here it's going to be x because that's on the hypotenuse. So we're going to have x squared equal to, and now it doesn't matter which order we put the other two in, as long as we square them and add them. So x squared is equal to 3 squared, add 4 squared. And then we just start working through the maths of this now, keeping this x squared over on the left-hand side. 3 squared we already know means that you multiply by itself. So this is going to be 3 times 3, which is 9. And then 4 times 4, which is 16. So I now have a calculation that I can add together. So 9 add 16 is 25. I've still kept this x squared on the left-hand side. Okay, making sure that you show in the examiner that you know that it's still x squared and not x here. Now at this stage, we don't want to find x squared, we want to find x. So here we do the reverse of squaring, which is square rooting. So it changes now from x squared to just x, and we have the square root symbol with the 25 underneath. And you need to now think about what number do you multiply by itself to make 25, and then that is our answer. So this one is 5, because 5 multiplied by 5 is 25. I haven't got units on there yet, so I go back to the triangle and check the units. So these are all in centimetres, so 5 centimetres for the answer. Okay, right then. So there is now 2 questions on the screen. So these you can use calculators for, so you can use your squared button and your square root button. You can also do these without a calculator, okay? But they are numbers that you can use calculator with as well. If you can pause the video, and then I'll give you some time, and then I'll start going through the answers. Okay, so I'm going to start with question 1. So first thing you have to do is label your hypotenuse. I'm finding the right angle, and then directly opposite it is the h, the hypotenuse. So this is the side with the x on that you can see there. So when I go to set up the answer, that is the side that will be on its own in the Pythagoras theorem. So x squared is equal to, and remember it doesn't matter which way round I write the other numbers, so 6 squared add 8 squared. And then if I work these out, remembering now to make sure everything is labelled and we've got it all set out neatly for the examiner. 6 times 6 is 36, 8 times 8 is 64, and then I'm going to add them to get 100. And then after that, once you've got down to this step here, you then need to do your square root. And you show in every step, so you're not missing anything out, you have to show them, so you're getting all your method marks. So x is equal to 10, because 10 times 10 is 100, but I'm putting units on the end as well, so 10 centimetres for that question. So if you can mark your work now as you go through it. Question 2, find your hypotenuse. You've got your right angle over on this right-hand side, so your hypotenuse is opposite that. Again, it's the x here. So x squared is equal to 9 squared add 12 squared. You're going to square each number, so 81 add 144. You're then going to add them, and that comes to 225. And then the last little step is to do your square root of that number, giving you an answer of 15. Now this time, go back and check your units are meters this time, so don't always put centimeters on there. This one is in meters. Lovely. Okay, so this is how far we've got so far. So we've done the first 3. Okay, we're now going to look at using Pythagoras Theorem to find the length of one of the shorter sides. We've only looked at the hypotenuse so far. So I'm going to run through this one with you. So you can see up on the top right, this is a calculator question. So I'm going to identify my hypotenuse, and I'm going to use that now as I go through. So right angle up on the top right, hypotenuse is directly opposite. So this is the 7 this time. So you haven't got the x as the hypotenuse, but I do set it up in the same way. So the 7 squared will be the one on its own. The hypotenuse is always the one there on the left-hand side. And then we've got our other 2 sides squared and added together. So when I first look at this, I think, okay, well, where am I going to go from here? I'm trying to find this x. Okay, initially it's going to be x squared, but at the end it'll be the x. So I need to do the reverse of what I have here in order to eliminate this plus 5 squared from that right-hand side. So I need to subtract 5 squared from both sides here. if I write that out properly, I will have 7 squared, take away 5 squared is equal to x squared. And it's gone from this right-hand side now because I've subtracted it from both sides. So what's going to happen when you work out the shorter sides using Pythagoras Theorem is you will have a subtract in there rather than an add. So 7 squared is 49, 5 squared is 25, and that is then equal to my x squared. If I work that out by taking them away, I'll get 24. And I'm down to the stage now where I've got x squared is equal to something. It doesn't matter the x squared's on the right, it would work out the same if it's on the left as well. It's an equation, they are equal to each other. So I can now write this as x is equal to the square root of 24. And here you are going to need your calculator. This 24 is not a square number, so you will need your calculator to find your decimal answer. And I'm going to give my answer to 1 decimal place. So 4.9 centimetres to 1 decimal place. You need to tell the examiner that you're rounding, need your units on there. It doesn't have to be 1. If the question doesn't say what to round to, then you can decide. Okay, but you just need to show that examiner that you have rounded. Okay, same as before, there's 2 questions for you to have a go at now. So if you can pause the video for me, and I'll go through them once you've had some time to pause and replay the video. Okay, so I'm going to start going through them. Labelling your sides of your triangle. 6 is your hypotenuse. It's opposite the right angle. It's your longer side. Those are the things you're looking for each time. So that's the one that's going to be on its own. The other 2 sides get squared and added together, giving you your first equation of 6 squared is equal to x squared, add 4 squared. You're then going to subtract 4 squared from both sides, giving you then 6 squared, take away 4 squared is equal to x squared. And we're going to do a little bit of tidying up now. So we have 36 from 6 times 6, 16 from 4 times 4 is equal to the x squared. Subtracting those, I get 20. And now I'm going to do the square root of this to get my final answer. And again, I'm going to do it to 1 decimal place. So 4.5, and this question's in millimetres. So I've got millimetres on the end there, and I'm saying that I'm rounding. Okay, so please check your answer and have a go at that one. Over on the right-hand side, question 2, your hypotenuse is the 24. This is the one that's opposite your right angle on your longer side. That's the side that should be on its own in Pythagoras' theorem. Giving you the first line of 24 squared is equal to x squared, add 20 squared. You're going to subtract 20 squared from both sides. So we now have 24 squared, take away 20 squared is equal to x squared. And then if we tidy this up again, we'll have 576, take away 400, and that's still x squared at that stage, giving you that x squared is equal to 176, and you square root that answer to get 13.3 centimetres, and I've rounded to 1 decimal place. Okay, so we've now run through squares and square roots, we've looked at the labelling, we've done finding the hypotenuse, and we're now and the shorter side, so we're now going to go on to some of the questions you might see in your upcoming GCSEs. So the first one I've got, overall, this is a 4-mark question. Okay, at this stage, you should now be thinking about highlighting your key information and picking out what the question's asking you to do, and then using that then thoroughly in your answer. So I'm going to read through the question. Gwen is asked to calculate the length x in the triangle above. Her answer is 14.1 centimetres. Without calculating x, explain why Gwen's answer cannot be correct. Okay, so we're not working it out, so it's only a 1-mark question. But we have to be able to say, without doing any maths, why. So let's pick out what's important in here. I didn't mean to do that one. Let me just rub that out. Okay. So her answer is 14.1. Now that answer is the length x. And the length x in this question is opposite the right angle. So that is your hypotenuse. So it's saying that the hypotenuse is 14.1. Now I've said it quite a few times in this session that the hypotenuse is the longest side and it is opposite the right angle. So yes, we are correct with opposite the right angle, but the other part of it is that it's the longest side. So if I compare my answers, the 14.1 to the 8.6 and 16.5, 14.1 is actually shorter than one of the sides that should be shorter than the hypotenuse. So that is the reason that we use in order to answer this question. So this is shorter than 16.5 centimeters, but X is the hypotenuse, so it must be the longest side. Okay, and that would be enough then to get you those marks in the exam. Part B of the question is where you actually go on and answer this, and we do work out what X is. So if you can pause the video, have a little go working out X, and I'll go through it in a minute. Okay, so I've already got the hypotenuse labelled. So this one is going to start as X squared, because hypotenuse is the one we're finding. Remember, it does not matter which way round I put the other two sides, as long as I square them and add them. So your first line should look like that. Okay. When you go through your squaring and adding, you will have 5,625 add 19,600, giving you then an X squared value of 25,225. At that stage, do not forget to do your square root. Okay. Some people will get there and think they've got the answer. Remember to relate it back to the triangle. If you've got an answer of 25,000 plus for this hypotenuse, when your other sides are 8.6 centimeters and 16.5, there should be alarm bells going off in your head to say that can't be correct. There must be another step. So that step was the square root, giving you then 100. I've done this wrong, haven't I? Hold on. Sorry, guys. I've just written down the wrong numbers here. I'm going to rub out this number, so sorry. Okay. Right, I'm going to go back up to this stage. I'm a step ahead. I'm giving you some hints for the next question. I am. So that's the first line. So that was alarm bells for me to know that that wasn't correct. So I'm going to go back up here. So it's 8.6 squared is 73.96. 272.25 for 16.5 squared. Adding them is 346.21. And then you're square rooting that. Now that's a much more sensible answer. I looked at that answer and I thought that can't be correct, and that's the type of thing you need to be doing as well. So 18, I should be writing here, 18.6 centimeters to 1 decimal place. Okay, so we've got it. And all together now, between the writing for part 1 or part A and that, we've got 4 GCSE marks. Okay, so you've got to forget about the hints I've just given you now. We're going to have a look at question 2. And we've got a rectangle I can see straight away with a diagonal line going through from A to C. This does say diagram not drawn to scale. Okay, so it's not 75 meters long or 140 meters on our page, but those are the measurements we're using for this question. Okay, so the above diagram represents a rectangular field A, B, C and D. The length of the field DC is equal to 140 meters. The width of the field A to D is equal to 75 meters. Calculate the length of the diagonal. So length of the diagonal is what we are aiming to find. So again, if you can pause the video, have a go yourself. I'll go through it in a minute. Okay, so labelling the diagonal first of all, the line A to C, you will see it written in this format where you've got the 2 letters from the ends of the line being used. So in regards to our rectangle first of all, and then onto a right angle triangle, you do have your hypotenuse, and that is the line A to C. Here's the right angle, directly opposite it is your hypotenuse. Now for this, I'm going to call that my X. Okay, so that I'm not using perhaps the AC. You can, if you want to write this down, you can write it as AC squared, and that's absolutely fine. But I'm going to use X as my value there. As long as you label it on the shape, on the diagram that they give you, then the examiner can follow that through. So starting, this is finding the hypotenuse question. So x squared is equal to, and then we're going to have 75 squared, add 140 squared, and then we're going to work through this. So just as you've seen a second ago, so 75 squared is 5,625. 140 squared, 19,600. Giving you an answer when you add, and then this is that 25,225. And then square rooting to get your final step, an answer of 158.8 meters to 1 decimal place. I'm going back, I'm looking at my diagram. This is the hypotenuse that I'm finding. It is the longer side, it's bigger than 75, it's bigger than 140. I'm happy that that's my answer. Okay, you can be doing those type of checks through. Okay, so we're on to our next question. So in a speedboat race, competitors travel 8.5 kilometers south from the start to buoy A. Then they travel 7 kilometers east, buoy B, and then travel directly back to the start. Calculate the total distance that competitors travel in the race. So before you begin this question to do with any maths, you need to be thinking about what is important in this. So go back with your highlighter and you highlight the key information. So in a speedboat race, competitors travel, so 8.5 kilometers south from A. Now that matches with the diagram. They've actually been quite generous. Sometimes they will put the numbers on the diagram, sometimes they won't. So 8.5 kilometers south is here, so that's okay to carry on. Then they travel 7 kilometers east. Again, that is marked on the diagram for you. And then they travel directly back to B. And they've even given you arrows on this triangle to show you the path that they are taking. And then we have to find the total distance that they travel. So that is the full distance around this triangle. So that relates to a topic called perimeter, where we're going around the distance of the shape and we're working out the perimeter, but we haven't got enough information at the start to find that perimeter, and we need to obviously find this missing side. So pause the video. You are allowed to use a calculator, have a go. And again, I'll go through this in a few minutes. Okay, so we're going to start by labelling the sides of the triangle. Here's my right angle down on the bottom left. Directly opposite that is the hypotenuse. So that is the side. Again, I'm just going to use X each time, but you can choose your letter or you can label that some other reason. You can keep it as H if you prefer. Okay, as long as you are showing what we're doing. So this is the side we're going to find. So this will be an adding question again, because we're finding the hypotenuse. Remember to square your numbers as you're adding them, giving you then 72.25, add 49, adding them together 121.25, square rooting at this stage to get down to your final answer, but I'm not missing any steps. I'm showing the examiner what I'm doing every step that you've got here, giving me an overall answer for that distance only, 11.01. We're in kilometers, and I've rounded to 2 decimal places this time. Now, don't think, oh, I'm done, I'm finished, I've done my Pythagoras Theorem, it's over. Go back and read the question, have a look at what we've highlighted. I've highlighted that calculate the total distance. So I now know that this hypotenuse is 11.01 kilometers to 2 decimal places. So when I go to find my total distance, my perimeter, I am going to be adding up around the outside of this shape. So in any order you want, 8.5, add 7, add 11.01, and then the answer then 26.51 kilometers to 2 decimal places. Okay, obviously if you perhaps for some reason didn't get the correct answer for what I've called as X, the hypotenuse, then the examiner will follow that through for the perimeter as long as you've got your workings and everything going on above. Okay, so there's 4 marks awarded altogether for that question. And on to the next one. So we have calculate the length of the side marked X. Now, when I initially look at this shape, I can see that I have two right angle triangles that are joined by a line going across here. And when I look at the top triangle, I've got two sides given to me. And when I look at the bottom triangle, I've got the one right-hand side there, the 2.1, and I'm trying to find the X. So if I go straight in to find this X, only using the bottom triangle, I haven't got enough information. I only have the 2.1 that I could use within that triangle. So there is something else that needs to be found, and that is that line that's joining these two. Sometimes you will see shapes being joined, and that line normally means that you've got to work that out. Now this time I am not going to use X as the labeling because that's already in the question. So I'm now going to label this as Y so that I've got something else, another letter that doesn't get confused. You're not allowed to use the same letter for a different value within the same question. Okay, so label that something else. Okay, so you're going to pause the video. You've got a calculator for this question. Have a go, and then I'll start in a second. Right then, so we're only going to look at the top triangle at the top. We're going to imagine that that bottom triangle isn't there. We're going to label the hypotenuse and we're going to work out what Y is. So right angle down on the bottom left, hypotenuse directly opposite it. So this is the 6.4. So when I set up Pythagoras Theorem, that will be the side that is on its own. And then I have the other two sides squared and added together over on my right. I need to subtract 4.7 squared from both sides, so that I will then have Y on its own there. And then I'm going to work through that then to give you 40.96, take away 22.09. And that will give you a Y squared value of 18.87. Remember, there is that extra step where you have to square root, and then giving you an answer for that part as 4.3 centimeters to 1 decimal place. So that is now the length Y. I have 4.3 centimeters that I can put onto the diagram and go on to use for the second part here. So this second part, you're only looking at the triangle at the bottom. You're trying to find X. So we have X squared, because that's the hypotenuse, it's opposite your right angle. It's going to be 4.3 squared, add 2.1 squared. So this is going to stay as an adding question for this part because we are working out the hypotenuse. That will give you an answer as we go through of 18.87, which we could have from above because we know that we've square rooted there. 4.41 for the 2.1 squared. 23.28 when you add them together. Next step and the last little bit is to square root your 23.28, giving you 4.8 centimeters to 1 decimal place. Okay, so and go back now and have a look. Right, the question said calculate the length of the side X. I've done that. I've got quite a lot of workings going on here, but I have worked out what X is. Okay, on to the next one. Now this question is a 6-mark question. So I can see I've got a right angle triangle. At the moment I can see there's a 15 centimeters at the top. It's not drawn to scale. And then the other bit of information that is key here is this bit that's in the writing. So the area of the triangle is 60 centimeters squared. And we have to find the perimeter. So there's a lot of different things going on with regards to bringing in our other topics, so area, perimeter, and so on. We've already seen a question with perimeter, but this one now involves area as well. So if we link this back to our area one, I'm going to start you off with one formula, and then I'm going to ask you to pause the video. The area of a right-angled triangle is the base multiplied by the height, and then halving. Okay, so see if you can use that formula now to pause the video and have a go working out what this height would be, the height here. Okay, so this is the side we're going to find to start. That's going to be the X. So pause the video and have a go. Okay, so we're now being told that the area is 60, so I'm going to put that in the correct place here. The base is actually what I'm going to use as the 15. Remember, the base doesn't have to be at the bottom of the diagram. It's going to be the two sides that are either side of the right angle that will make up your base and your height. So I'm going to now have 15 times h. I'm going to change that h into the x because I don't want to confuse the h with the hypotenuse. So I'm going to use the x here instead. Now there's different ways in which you can sort of solve and rearrange this. One of the ways is to get rid of this dividing by 2 by reversing it and doubling the 60. Another way would be to half the 15 and then use that. Okay, both ways would work out the correct answer. So I'm going to do it by doubling the 60. So I'm going to times both sides by 2. So I'm going to have 120 is equal to 15 times some number that I'm going to work out. And then I'm going to divide both sides by 15 to get the answer for this height, which comes out to be 8 centimetres. I'm going to go back up here now and write this onto my diagram so that I have the information as I'm going through the question. So remember now, I'm going to go back and it says I need to find this perimeter. Perimeter is the distance all the way around the outside. I haven't got enough information yet. There's still a side that is missing. So I'm now going to call this side y, and I'm going to work through that answer. So y is my hypotenuse. I'm going to write hype now because I can see there's a h in my area and I don't want anyone to get confused with what it is. So we've got y squared is equal to 8 squared. 8 squared plus 15 squared. I'm going to square both values, so I've got 64 add 225. I've missed my square there. Giving you 289. And then if you take your square root then to get your answer, you will have 17 centimetres. Now here, I now have enough information to find the perimeter. So the perimeter is the distance around the outside. So this side is now 17 centimetres. I'm checking it against the other sides. It is the longest side. I'm happy 17 makes sense. And now I start to add what I have going around the edge. Okay, so I've got 15, add 8, add 17 to work out, giving you a final answer of 40 centimetres. And that then is your 6 marks, working through what your area was, working through finding the hypotenuse, and then finally onto the perimeter. So we're going to look at one more exam question, and that's this one. So we've got in the diagram, the area of the triangle ABD is 56 centimetres squared. Work out the length of CD. Okay, so we've got area and we've got ABD. So it's not the full triangle you can see. A to B to D is this left-hand triangle. And we know just the area of that is 56. And then we're going to aim then to find the length of C to D. So back now and thinking about what you did in the last question, where you used the formula of area equals base times height and halving, you're going to start with that. So pause the video, try and write that formula down and work through what would be the height using the BD line. Okay, so I'm going to call this height X. Try and work through that to find side X for me. Pause the video now and have a go. Right then, so area formula, area right angle triangle, base times height, and then we half it. Now then the information in the question at the top is 56. The base of this left-hand triangle only is 14. The height I've said is X, and I need to half this. Now I'm going to stick to the same method as I did before, where I'm going to double this 56 by doing the same to both sides. So doubling 56 is 112. So 14 times some number is that, and then you can divide by both sides by 14 then to work out your X, which is the height, to give you a height of 8. Okay, so 8 centimetres here. Then the question says, because we've only done part of the question so far, says find the length CD. Okay, so CD I'm going to call Y, and I'm only now looking at the right-hand triangle, and I'm going to use Pythagoras Theorem. The question won't say use Pythagoras Theorem. You're going to have to identify, okay, it's a right angle triangle. One of the methods I could use is this. Have I got enough information? Yes, I have, because I've got now 2 sides and I want to find the third. So y squared, 8 squared plus 6 squared. Adding those and squaring them, I've got 64 plus 36, giving me then 100 when I add them together. And then the last step of that one, this is the square root of 100. And you're thinking of, remember this is a non-calculated question, you're thinking of what number do you multiply by itself to get 100? And that number is 10. I'm putting units on the answer. I haven't rounded this time. So we are just saying the answer is 10 centimetres. Okay, so I'm going to now have a look at, these are the things we've covered today. So we've done quite a lot today. And we're going to do one little thing to finish off. So we've got a spot the mistakes question. So you've got a triangle on the left hand side and the question says to calculate x. I'm giving you an answer over on the right hand side and I want you to find the mistakes. Now I'll give you a hint. I've picked up 5 errors in this. So can you pause the video and see if you can find those 5 errors, please? Okay, so the first one was, if we think about labeling this triangle, your hypotenuse is your 7, it's opposite the right angle. So that should be the side that is on its own. So this question is not going to be an add-in question. So there is a mistake. There is a mistake here. That should be a subtract. Okay, that there. There's also another mistake, or 2 mistakes on the next line. If we go back to the very first thing I went through with you, squaring means that you times by itself. But what's happened here is that the person is times by 2, it's multiplied by 2. We've doubled this number. So the 14 and the 10 are both incorrect because they should have been times by itself, not doubling. And then even if they had got 24, which obviously is now wrong, but even if that was 24, when we go down to this last line, where they should have taken the square root of 24, what's happened is they've halved it. So the 12 is incorrect, even though obviously it's coming from the wrong answer anyway, but that should have been what 2 numbers multiplied together to make 24, and you would need your calculator at that stage there. And then the final thing that is wrong is that there are no units on here. They should say centimetres on the end, should relate it back to the question. So we've got 5 errors. So I'm going to show you now is what should have been there. Okay, so obviously you've got your formula. Then it's going to be a subtracting question. Once you've rearranged there, you're going to square them, you're going to subtract them. And it does actually come out to be 24, but obviously the 24 on the left-hand side is from the wrong method. So that would be marked wrong in the exam, because the examiners will go back and check the method you're using, not just look at your answers. And then the square root of 24 then is 4.9 centimetres to 1 decimal place. Okay, so that's the end of today's session. Thank you for joining us. Back to you, Mr. Casey.
Okay, thank you, Mrs. Dixon. I hope you all found today's session useful. You may have noticed on the live question answer, there was a Microsoft Homes link there. If you can possibly fill that in, and it just gives some information about future events, just so we can keep in touch with you. The next session, running next week, will focus on right angle trigonometry and will be taken by myself. So hopefully we'll see you all then. Okay, goodbye.